So the first two questions on the practice test are super easy. What I recommend for you to do is to think of a simple logarithm that you already know. Let me move this to the side over here. So let's pretend something simple, like let's say log base 2 of 8. Okay, log base 2 of 8. We should all know what that is. What is the answer? The answer is 3. Now, what I want you to do is ask yourself, why is the answer 3? Well, the answer is 3 because 2 to the third power equals 8. And ladies and gentlemen, this shows you the pattern of how you're going to be moving things around. Okay, this has your logarithmic form, and this is your exponential form. Okay, so if you just look at this movement here, the base on the logarithm became the base on the exponent. The answer over here became the power, and this number became the answer. So that's the movement that you're going to have on these problems. So on number 1a, they want you to change it to exponential form. So you have log base 3 of this equals this. So over here the base became the base, so this base is going to become the base. There's a 3. Okay, and what else? The answer over here on the logarithm became the exponent. So the answer of the logarithm becomes the exponent right here. So it's going to be a negative 4 power, and it equals what? Well, in this case the 8 becomes what it equals. So in this case the 1 over 81 becomes what it equals. Okay, now at the end of it all, after you do that movement, you should double check and see if this actually makes sense. 3 to the negative 4 power, that does cause it to move down, so that's where you get the 81 on the bottom, or you could even check it on the calculator. Anyhow, let's move on to 1b. Okay, so same deal. The base on the logarithm is going to become the base on the exponential form. So 1/2 is the base. You can put in parentheses if you want. What's the power going to be? It's going to be the answer up there, the negative 5. And then it's going to equal the 32. Okay. So let's take a look at 2a and 2b. These are in exponential form, and you want them in logarithmic form. So if we once again look at this most basic logarithmic equation or logarithmic expression that we know, log base 2 of 8 equals 3, in exponential form, it's like going from here back to this. So the base on the exponential form has to become the base on the logarithm. So on number 2a, our logarithm has to have the base what? Base 3. This exponent became the answer on the logarithmic form. So the exponent is going to become the answer on the logarithmic form. And last but not least, we have the answer 1/9. Where does that go? That's going to go right in there, right? Because the answer on the exponential form becomes what you're taking the log of in logarithmic form. So you're going to have a 1/9 right here. There's your answer. So it's really, I recommend to do something really simple, like log base 2 of 8 equals 3, and then say, why does it equal 3? Because 2 to the third equals 8. And there you have your logarithmic form and your exponential form. And then you could use that as a guide on how to move. The base becomes the base. The answer on the logarithmic form becomes the exponent on the exponential form. The number you're taking the log of becomes the answer on the exponential form. So that's as easy, or that's the advice I have for these questions. And there's only 2 of them out of the 20. 2 out of 20, right? 20 questions on the test. So let's look at number 2b. So let's change to logarithmic form. It's going to be log base what? Base 1/4, because the base is 1/4. And the equal sign's right here. The exponent becomes the answer, negative 2, and the 16 comes in here. And there's your answer. Log base 1/4 of 16 equals negative 2. Number 3 may look like a confusing question, but it's really pretty simple if you think about it. It says at time t, there are 343 t to the 17th power bacteria of type A and 49 2 to the t plus 7 bacteria of type B. what will the number of each type of bacteria be equal? When will the number of each type of bacteria be equal? So simple as that. When it says when will it be equal, let's set them equal to each other. So there's our equation, and the next thing to do would be to attempt to get both of these guys to get the same base. If we could do that, it'll be really easy because we could just eliminate the bases and the exponents come down. So I'm looking at 49. I know that 49 is 7 squared, right? And with the calculator, I want to check and see if 343 could be 7 to a certain power. And after doing that on the calculator, 7 to the third is 343. So I verified that on the calculator. So let me rewrite both the 343 and the 49 as base 7. So that's what I've done. I rewrote it as 7 to the third, and it's still to the power of t plus 17. And the other side we have 7 squared, and it's still to the power of 2t plus 7. So what we need to do now is when we have a power to a power, you multiply. So you're going to have to distribute 3 times 3 and 3 times 17. And you're also going to have to distribute 2 times 2 and 2 times 7. And also, after you distribute, you could apply log base 7 on both sides, log base 7, so that these guys cancel out. So you're going to have a new equation, which will be 3 times t is 3t, 3 times 17 is 51. Bring down the equal sign, and then 2 times 2t is 4t, and 2 times 7 is 14. Okay, so we have that equation, and let me rewrite that equation up here. And let's zoom in on that equation and solve it. I'm going to subtract 4t on both sides to move it to the left. And that will give me the new equation, negative t plus 51 equals 14. After that, I'm simply going to subtract 51 on both sides. And of course, this cancels. I'll get the new equation, negative t equals negative 37. So my final answer is going to be t equals 37. So the answer to the question, at what time t will the bacteria be equal to each other? Well, it'd be 37. I don't know if it's 37 hours, 37 minutes. It doesn't really specify in this word problem. But that's how to do number 3.